Okay, now we've reached the exam questions. So I just took these questions from Lico Met Education. Yeah, this question is actually nice. So I was like, okay, I'm gonna use this question. So this is a really good program. I'm sure most of you are familiar with this. And yeah, this is from the Hotline app, and we're gonna deal with natures of roots, and we're gonna deal with the exam questions. Please do stick around so that we do question two. I'll call this the bonus question because it looks so familiar that I feel like it was there in our June paper, and I was like, yeah, this question needs to be done, and we're gonna do it today, and we're gonna get it done. So please do stick around. But let's start with the basics first before we approach the level the level 4 question, right? So let's start with question 1.1.1. So with question one is that I want you to remember that when we're dealing with these natures of roots, we're gonna always deal with making the equations in standard form. And please do remember the formula by head, ax squared plus bx plus c, because this is going to help us throughout the topic of natures of roots, because we're dealing with these throughout. So let's get to it. Okay, let me switch my screen, and then let's just start so that we don't waste time. So we're gonna say that, okay, so it says determine the values of p for which the roots will be equal, right? So we have x squared plus open brackets p plus 3 is equals to px, right? So normally what I do with this question is I first ask myself is that we're dealing with a quadratic equation, and we have to ask ourselves that our quadratic equation has to be in the form of what now? Ax squared plus bx plus c, right? And for it to be in this form, we have to check from our equation. Is our equation in standard form? It's not, because we have the px here and it's kind of behaving like bx, and when we look at it, we're like, now we can actually rearrange this to be in this form, ax squared plus bx plus c. So I'm gonna say that we're gonna have x squared here, we're gonna have x squared plus p plus 3 minus px. So we said for which the equation has equal roots, then we're gonna equate it to 0. And then from there, we're gonna say that, okay, some people may not feel too comfortable around here, although it is already in standard form, but they'll be like, nah, I wanna put it in a form that's the same way as ax squared plus bx plus c. So then they would say that, okay, to make it in that form, I would just say that, okay, we're gonna have basically x squared, right, minus px, and then I'll just keep my signs, p plus 3, and then I would say it is equals to 0. Then from there they'll be like, okay, now it's in standard form, and we know that it also relates to the quadratic formula. So we know that b squared minus 4ac would be equals to our discriminant, as we say that our discriminant always behaves, our discriminant tells us the nature of our roots. You see, so the discriminant tells us the nature of our roots, whether it's going to be real and equal, in this case equal roots, so we're going to equate it to 0. You do get a mark for saying that, okay, we can say that, okay, delta, or our discriminant, must be equal to 0. There's your mark there. Then you're gonna say that, okay, we're going to substitute now the values, right? Let's substitute the values now. So we're going to say that where we see b, we're basically going to put negative p, because then we substituted, right? We what's this? We rearranged, we put it in standard form. So it becomes negative p squared minus 4 into a. A in this case it's 1 from the formula. Remember the formula? I mean from the equation, I mean. It's 1. And then our c is going to be p plus 3. So don't be confused, guys. When they say discuss the nature of roots, sometimes they can ask you to discuss the nature of roots, and then they give an equation. There you'd have to solve. You'd have to ask this. You'd have to basically find the value of the discriminant. Don't confuse it with determining the values of a certain variable and stuff. And remember, the variable will not always be the constant will not always be a single it will not always be a single number. Sometimes it may be a binomial mixed with a variable, but it still behaves as a constant. So it's tricky sometimes, but you should get used to it. That not all the time it will be a value. It will be a binomial. It can be mixed with a variable and a number. So negative p squared becomes what now? This becomes p squared, right? We know that it's raised to an even exponent, so it's p. minus 4. You can apply your BODMAS here. We know that 1 times p is p. We also know that 1 times 3 is 3, positive 3, and then you can distribute the 4 inside the bracket. So then this becomes what now? So we're going to have p squared, right? P squared into negative 4p, right? Yeah, into negative 4p. P squared into negative 4p, and then negative 4 times positive 3, right, is negative 12. Okay, can you see that now? It actually brings us back to a quadratic equation again. A way that you'd see like, okay, this looks familiar right now. Then we know that, okay, now it's a quadratic here. I can open my two brackets. I'm gonna open two brackets here, and then I'm gonna equate it to 0. This becomes my p, that's my p. And what are the values? So we know that the factors, we have to find factors of 12, factors of 12 that give us 4, right? So we know that we have 6 times 2, right? It's 12. We also know 4 times 3. In this case, I don't think 4 times 3 would work in order for us to get our middle term. So let's erase this one. I think 6 times 2 would work. So what would it be? So would have a positive and negative inside. So let's say this becomes plus 2, this becomes minus 6, right? Because 2 minus 6 gives us negative 4. 2 times negative 6 is negative 12, and this brings us back to our way of how we'd solve for x. You know how we're used to it? Yeah, so we can conclude that p is either equals to negative 2 or p is equals to 6, and there we go. If you want, you can sketch it. If you want, you could do a rough sketch, but you don't have to do a rough sketch because it says determine the values of p for which the roots will be equal. So another one would say that, okay, I would substitute here negative 2 squared minus 4 into negative 2 minus 12. It should give me 0, and when I put in 6, it should give me 0. So what can we say about these? Can we say that these are two unequal real roots? Yeah, they are. They are two unequal real roots. Two unequal real roots. So yes, thank you guys. Let's get to the next question.